This is the screencast for example 2 of section 4.8. We're going to make some indirect measurements. So from the top of the 100-foot tall Altgeld Hall, which by the way is the math building at the University of Illinois where I got my degree. Woohoo! ILLINI. Anyway, a man observes a car moving toward the building. So this car, although I believe it's moving, looks like it's moving this way, is moving towards the building. So the blue car is the first position, and then the red car is the second position. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Well, if we're looking for how far the car is traveling, we're looking to find x here. D would be the distance of the car at that second spot of observation. So the first position of the car, the angle of depression from the top of the building is 22 degrees. The second position is 46 degrees. So I actually have two different right triangles that I'm dealing with, so I am going to set up two different trig expressions. The first one I'm going to set up is the blue one. The tangent of 22 degrees is the opposite 100 over the adjacent. Now the adjacent side is both of these sectioned pieces here, this whole bottom adjacent side, so it's going to be x plus d. Now the second triangle, the red one, is going to be associated with the red car, is the tangent of 46 degrees equals, opposite side is still 100 degrees, over d. So now I can solve, see I have two variables in this one, and I have one variable in this one, and I'm trying to find just x. So if I plug in what d equals with this equation into d for this equation, I'll only have x left as a variable. So I'm going to solve this equation for d. Then I'll plug in to this equation. Now, I don't want to leave a fraction in a fraction with a plus in the denominator. That is a mess. So I'm going to actually do a little work to this side first. I'm going to multiply both sides by x plus d. And I'll get x plus d times the tangent of 22 degrees equals, let's see, 100. Now I can distribute Nope, I'm actually going to divide both sides by the tangent of 22 degrees. Why would I make that even messier than it should be? So now I have x plus d equals 100 over tangent of 22 degrees. Subtract d from both sides. And now I have x equals 100 over the tangent of 22 degrees minus the expression I got from d from the other equation. So that would be 100 over the tangent of 46 degrees. And again, making sure I'm in degree mode because we are working with degrees in this equation. I plugged that all in my calculator and I got that the car traveled 150.94 feet between the times of the two observations. The now try problem, number 7, asks us to find the height of the Eiffel Tower. The angle of elevation of the top of the TV antenna mounted on top of the Eiffel Tower in Paris is measured to be 80 degrees, 1 minute, and 12 seconds. So yes, we are going to bring back from section 4.1, converting degrees, minutes, and seconds just to degrees. So I did that over here, and I got 80.02 degrees, which is the angle of elevation to the top of the antenna on top of my beautiful little Eiffel Tower. And then that is at a point of 185 feet away from the base of the tower. We want to know how tall the tower is, plus the TV antenna. So I have a right triangle again that I can set up some trig to find the height of the tower. So I'm going to say I know this angle and I know its opposite, or I'm trying to find its opposite side and I know it's adjacent. So I'm going to say the tangent of 80.02 degrees is the opposite side over adjacent side. So I'll multiply both sides by 185. X is going to be 185 times the tangent of 80.02, which my calculator got to be 1,051.33 feet tall, which I believe they use the metric system, so they don't know what that means, and that's fine.